Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Hidden Wizard by Felix Hiller. And here are the rules. I'm assuming standard Sudoku rules, right? Because it doesn't say, but I'm assuming standard Sudoku rules. Yeah, that's almost certainly given. Standard Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. Hidden doublers. One cell in each row, column, and box has a hidden doubler. The value of each doubler cell is double its contained digit. Each digit only appears once in all doubler cells, so there are no repeats, again, in the doubler cells. So this is just typical doubler cell rule. I'm not sure why it's called hidden doublers, though. Maybe it's so you can have a hidden wizard? I'm not sure. Anyways, region sum lines. Box borders separate region sum lines into segments. All values in each segment on the line sum to the same value. Different lines may have the same or different sums. The line colors have no significance and is just to differentiate lines. Okay, so these are also region sum lines. The point, though, is that essentially this is a separate line from this. That's the reason why they're different colors. Okay, good to know. So that means, okay, so for doublers, if, say, this were doubled, instead of its value being 3, it would actually be a value of 6. And there's 1 in every row, column, and box. 1 per. One in exactly 1 for every row, column, and box. That's important. And the region sum lines is the sum of all values the box borders divides each region sum line into segments with the same, which sum to the same value if you add up the values of the cells on this region sum line. And that's where you have the doubler rule set going into account, right? Right. So for an example, if the sum of these values, say this value was 2 and this value was 5, that would mean this value of this cell would have to be a 7, right? So if this were 2, if this had a value of 2, and say this were 2 non-doubled, and this were 5, this would have a value of 7, and therefore would have to be 7. If this were, like, say, 1 doubled, which is still a value of 2, this would, and this is 5, this would still have to be 7, right? Because this is value of 2 plus 5, that would mean that it adds up to a value of 7. And that's how region sum lines work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so the thing that I noticed first was, well, this region sum line has 2 cells which are only two regions which are only 1 cell, and they are both on the same row. They obviously can't be the same digit, so one of those 2 has to be a doubler. So the rest of the row cannot be a doubler, right? Because one of these 2 has to be a doubler because they must add up to the same value. Well, since they add up to the same value, that means it's doubled of 1, 2, 3, or 4, obviously. And it's 3 digits, though. So the value must be 6 or 8. Well, if it's 6, that would mean the doubled value is a 3. but then this can't be 1, 2, 3. So it cannot be 6. Therefore, it must be 8. One of these is 8, and the double value is a 4, right? Which means this cannot be, this adds up to 8, and none of the values are doubled. So it cannot have a 4 because we have a 4, 8, 4, 8 pair in that row. So this has to be 1, 2, and 5 here, which means the remaining cells have to be 6, 7, 9, and 3. So this is 6, 7, or 9 because 3 can't be here. And this is 3, 6, 7, or 9. And one of these is 3. This can't be 3, therefore this must be a 3. This is also one cell, and it's the same as that. And therefore, and if both of these were doubled, the problem with that is that they would have to be the same value doubled, right? Because this is the same value as this, and if these are both doubled, this would have to be 8, and this would be 4 doubled, and then this would be 4 doubled. But that's not allowed by the hidden doubler rules. So these cannot be the doublers, therefore this has to be the doubler, and it's 4. So this is 4, this is 8, this has to be 8. The rest of the row cannot contain a doubler, and the rest of the box cannot contain a doubler. So none of these are doublers. So this is doubler adding to 4. This must be, it could have a doubler in it, so let's not do that yet. But either way, I think it has to have a 1 in it. Right? It could be, if there's no doubler, it's either 1, 2, 5 or 1, 3, 4. So this has to be at most 1 through 5. And if it does have a doubler, it could be 1 doubled with 2 and 4. It could be 2 doubled with 1 and 3. And those are the only possibilities. Also, I noticed for this line, again, you have 2 digits which must be the same value in the same column and actually in the same box. So one of those 2 must be the doubler. So therefore, none of the same box can have the doubler, and none of the same column can have the doubler. Well, we also know that these 2 so one is double the other one, and it cannot be 4 and 8. It cannot be 1 and 2, or 2 and 4, so it must be 3 and 6 here. So this has to be 3 and 6 and 3 and 6 here. Well, if this is 3, this would have to add up with 1 and 2, so this can't be 3. Well, actually, no, it's doubled. So the value has to add up to 6. And the thing is, what I noticed is that these 2 cells must add up to this value, and these 2 cells must add up to this value. Well, this is the same no matter what, so therefore these 2 cells must have the same value, and they have to be doubled. One has to be doubled the other. So therefore these 2 are a pair of doublers, and the rest of the box cannot contain a double. So we know one of these is a doubler, we know one of these is a doubler. Therefore, where's a doubler in row 8? It has to be one of those 2 cells, which means this can't be a doubler and this can't be a doubler. If this cannot, okay, it's a value of 6. One of them has to be doubled. So it cannot be a value of 1 and 5 because none of those values can be doubled in the other one, right? In fact, actually, it has to be 2 and 4. And if you took the 4 being doubled, the problem is it would require 2, but that would have to add up with 6. So therefore, this cannot be 1 or 2. It has to be 4 here. And one of these is 1, and the other one of these is a 2 undoubled, and the other one is a 1 that's doubled. So this can't be 4. This has to be if it's 3 doubled, the problem is we already have a 3 that's doubled here. So therefore this must be a 6. What are the remaining digits in this row? Or sorry, this column. It's 1, 4, 5, 7, or 9. This can't be doubled, and therefore is a 6. This can't be 5. This can't be 5. Well, we have a 1, 2, 1, 2 pair in column 6, which eliminates 1 and 2 from the rest of the column. So this cannot be 1 or 2. Therefore, one of these two is a 1, and therefore this can't be 1. Can this ever be 5 anymore? No, because it requires 1 and 2 to be with it. So therefore, this has to be... and in fact, I guess it still could be 1 and 3 here, and then that would be 4. Or 1 and 4 here, and this would be 3. That's possible. Mm, 3 already has a doubler here. So therefore, this can't be a doubler. And this can't be a doubler. So 3 has to be one of these 3 cells. The remaining digits here have to be 3, 6, 7, 8, 9. This can't be 3, though. This can't be 6 either, because of the 3, 6 pair in the box. These can't be 3, because of those 3. Huh. Therefore, if this were a doubler, it would have to be 6, 7, 8, or 9. That would mean this is at minimum 12. And the rest of the cells would have to add up to 10 at minimum. So this segment would then add up to 22, which 2 cells which don't have a doubler cannot add up to. So this cannot be a doubler. Therefore, this is a doubler, which means none of these are a doubler. This has to add up to this has to be at least 6, which means the rest has to be 1, 2, 3, 4 at minimum, so it's 16 at least. Therefore, this must be a 9, and add it up to 17. So this can't be a 9. This can't be 9. One of these, then, has to be a 9. Has to be a 9, not is not. So therefore, this can't be a 9, because one of these two has to be. This can't be 9, and it can't be 8. The 3 cannot be here, because again, if you tried it with adding this without a 3, the minimum would be 1, 2, 4, 5, and 6, which adds up to 18, which is not allowed. So therefore, this can't be 3 either. None of these are 3. This can't be 3. Where is the 3 in the row? It has to be here, which means the remaining cells in this box are 6 through 9. So this is 6 through 9, 6 through 9, 6 through 9, but this can't be 6 because of that 6. This can't be 3 now because that's 3. The remaining cells here, so they're either 1, 2, 3. To add up to 17, it's either 1, 2, 3, 4, 7, or 1, 2, 3, 5, 6. So that's why we need the 3 had to be here. So therefore, this is 6 or 7. And we have a 6, 7, 6, 7 pair in row 8, which eliminates 6 and 7 from the rest of the row. So this can't be 6 or 7. This can't be 6 or 7. The rest of this is 1, 2, 3, 4, or 5. This cannot be 4. These can't be 3, obviously. So 1, 2, and 3 cannot be here. 6 and 7 can't be here because of the 6, 7 pair. So this has to be 4 or 5 with 8 or 9. Okay. Well, where is 1, 2, and 3? 1, 2, and 3, one of them has to be here. And only one. Where's the other one, though? On the line, it has to be here. So this cannot be 3. And it can't be 5. This is 1 or 2. Therefore, where is the 3? It has to be here, then. Which means this can't be 3. This must be a 6, which makes that a 3. Therefore, this is the doubler. This is not the doubler, so this can't be the doubler. Which means this is the doubler. So that's a 1, and this is a 2. This can't be 2 anymore. This can't be 2. This can't be 1, so this is 2. Therefore, this can't be 2. This can't be 2 anymore. Therefore, this is 1, which means this can't be 1. This can't be 6 because of the 6. This is 2 with 1 out of 4 or 5. 6 has to be one of those two. That's fine. Um, hmm. Okay. This is at minimum 15 because it has to have a 9 and it has to have at least a 6 here. Therefore, this total here is 18 at least. And 2 digits without a doubler cannot add up to 18. Therefore, you need a doubler there. So we have a doubler here. One of these is a doubler, and this could be a doubler. We don't know. What are the remaining digits here? It's 1, 3, 5, 7, 8, 9. This can never be 1 because it can't be doubled anymore if it's 1. This can't be 3 because of that 3. It's 5, 7, 8, or 9. It cannot be 5 because of the 1, 5 pair in box 5. It can't be 8 because of that 8. So it's specifically 7 or 9. Interesting. Oh, this can't be 1, again, because one of these two has to be a 1 in this box. Ah, well, where's the 3 then? This can't be 3, this has to be 4. So it could be 1, it cannot be 1 doubled with 2 anymore. And it cannot be 2 doubled with 1 and 3 because this has to be 4 on it. So this has to be 1, 3, and 4. So this is 3, this is 1. This can't be 3, this can't be 1, so this is 5, which makes that a 1. So none of these are doubled. The remaining digits here are 2 and 5 with 6 or 7. So it's 7 plus 6, which is 13, or 7 plus 7, which is 14. It's still possible this is not doubled. We know that the 5 is here. This is 3, this is 3. We have enough 3s to eliminate all the possibilities here. So 3 cannot be here, or here, or here, or here. So this must be 3 in this corner. And we now have, that's 3 in the corner. We celebrate. We have 8 3s now. We know where the last one is to be. It has to be here. And this, again, cannot be doubled because the 3 already has a doubler. One of these has to be doubled, and it has to be at least 5. That doesn't really help us much. 2 has to be 2 has to be one of these two cells. And that can never add up with any other single digit to add up to 13 or 14. So one of these must be doubled, which means the rest of the column and the rest of the box are not doubled. So one of these is 2. It adds up to 13 or 14. So this is either, if it's 13, it could be 2 doubled with 9. If it's 14, it could be 2 doubled. Well, it cannot be 2 doubled there in that instance. Right, because then that would be values of 4 and 10, and you can get the 10 without being doubled. So if it's 14, that would mean it's 2 with 6 being doubled. So this is 2 with 6 or 9. What has to be remaining has to be a 4 here. 4, this can't be 8, so therefore this must be an 8, which makes this a 4. These can't be 8 anymore. This has to be 7 or 9, which means we have a 7, 9, 7, 9 pair, in row 5, which eliminates 7 and 9 from the rest of the row. This can't be 7. This can't be 4 because of that 4. Remaining digits here have to be 1, 2, 5, and 6. Okay. This cannot be doubled because of the doubler in the 1. Where is the doubler now? In the rest of the box, it has to be here. So this is at least 14, which means this cannot, well, this can't be 1, because if it were 1, 1 and 13, which would have to be a doubler, which is not allowed. You would have to have 6.5 doubled, which is not allowed. So this cannot be 1. This could be 4 with a 5 doubled to add up to 14. If this is 14, this could be 4 with 5 doubled. It could be 5 with 9, but the 9's not allowed, so that doesn't work. So this can't be 5, if that's the instance. If this is 7, it would have to be 7 and 7, which is not allowed. So it specifically have to be 4 with 5 doubled if this is 7. If this is 9, that means this is 18 in value, which means this could be 4 and 7 doubled? Is that right? Yes, 7 doubled. Either way, this has to be doubled. So this is the doubler, which means the rest of the box cannot be doubled and the rest of the column can't be doubled, which leaves this as the doubler, which means this can't be doubled, which leaves that as the doubler, which means this can't be doubled. So this is the doubler. So again, if this is 9, it could be 4. This actually has to be 4 no matter what, because this is always a doubler in value. 9 doubled is 18, and no 2 digits, and without a doubler, you can't add up to 9. And again, we tried 7. 7 doubled is 14. You could have 4 with 5 doubled. You cannot have 5 and 9 because the 9 is no longer allowed, and you can't have 6 and 8. And you can't have 7, 7, obviously. So that only works with a doubler. So this is always a doubler, and therefore this must be even, which makes this a 4. So this is a 4. Either way, one of these is a 7 as a doubler. So we have 1 as a doubler. So 2 cannot be a doubler here. This can't be 1. Oh, that's actually very important. Is it? Maybe not. Yeah, it's not that important. Well, this is at least 6 and 9 plus 3 and 2. So that's 20. So this is 20 in value at least. If this were 6, 3, 7, 9, that's the most it could be, right? Well, if this was 6, this would be 7, 9, and this would be 3. But that would be an odd, well, it could be odd, I guess. What's that value? 6, 7, and 9 adds up to 22. 3 adds up with that to 25. If you subtract 9 from this, or actually, I guess, yeah, if you subtract 9 from that, you would get 8 doubled, which is a possibility. So this could be 6. We know one of these is a 2. Okay. Well, there you go. Every doubler, again, every digit must appear once in the doubler cells. This can't be 2. This can't be 2. Where is a 2 in this box? It has to be one of those 2 cells, which means this can never be 2 in this doubler. The 2 in this box has to be one of these 3 cells, so this cannot be 2 as a doubler. Therefore, we know where is a 2 as a doubler. It has to be here. So this is 2. This can't be 2. 2 doubled is 4. It could add up with 9 to add up to 13, but it cannot add up with any other digit to add up to 13 or 14. So this must be 9 then. These can't be 9. Therefore, this makes that a 7, which makes that a 6. This can't be 6 or 7. This can't be 7. These can't be 9. Therefore, this is 13, which means this can't be 7. This is 2, 5, and 6 added together, which makes this a 7. That makes this a 6. So it must be 1, 2, 3, 5, and 6 adding up to 17, and not the 4. So this must be 2 and 5. These can't be 5. We now have a 4, 8, 9 triplet in row 9, which means that we have to have a 5 or 7 in the rest of the row. This has to be then 4 with 8 or 9. We have a 5, 7, 5, 7 pair in column 2, which eliminates 5 and 7 from the rest of the column. Therefore, this can't be 7. What are the digits in the rest of the column then? 1 has to be here, and 2 has to be here. Well, since 1 has to be one of these 3 cells, because it can't be any of these, it cannot be in this column either. So this cannot have a 1. Now we have a 5, 7, 9 triplet in the rest, in this box and in the rest of the column, which means the column cannot contain a 5, 7, or 9, so therefore this is a 1. And the rest of the box cannot contain 5, 7, or 9. So this is 1, 2, 4, 6, or 8. And this can't be 4. This then could be 8 doubled with 6, which would add up to 22. Or it's 6 doubled with, or 8 doubled with 4, which adds up to 20. Or 6 doubled, well, okay, hold up. This cannot be 2, 5, or 6 doubled. Right? Because we know 2, 5, and 6 have to be here. Therefore, and it can't be 1, can't be 3, 2, 3, or 4. So this has to be 7, 8, or 9 doubled. Well, that means we have a 7, 8, 9 triplet in the doubler cells. So 7, 8, and 9 cannot appear in the rest of the doubler cells, which means this must be a 5. Then this has to be a 6. Well, this adds up to, at minimum, 20. So therefore, it must add up to 20. Because this is only adds up to 20 at its maximum. So therefore, if you tried the max for 8 here, this would have to be the minimum. So this would be 2. This cannot be 2. This would have to be 6 and 9. Well, now we have a 6, 9, 6, 9 pair. We also have 4 and 8 here. So this can't be 4, 6, or 8. It's a 1, 2, 1, 2 pair. This can't be 2. So this must be 1, which makes that a 2. Neither of these can be 2. Where it's a 2 in this column, it has to be here. This can't be 8 anymore. 5 doubled with 4 adds up to 14, which means it's 7 doubled. So this is 7 doubled, which makes this 9 doubled, and that makes this 8 doubled. So this can't be 8 anymore. This can't be 9, so this is 4, and that's 9, which makes that an 8, which makes that 9. This 8 means this can't be 8, so this is 9, which makes that 6, which makes that 9. This can't be 5 because of that 5, so this is 7, which makes that 5. This can't be 8 or 9, so this is 4. This can't be 4 or 9, so this is 8, and now we're just doing Sudoku. This can't be 9. This can't be 7, so this is 9. This can't be 1 or 2. This can't be 6 because of this 6, so this must be 7. Remaining digits here are 1 and 2, and this has to be a 7. This can't be 6 because of this 6, so this is 5, which makes that 6. This 5 means this has to be 2, which makes that 5. That 2 means this has to be 1, which makes that 2. Remaining digit here is an 8, so this is 8. This can't be 8. Remaining digits, this can't be 7, so therefore this is a 5, which makes that an 8. This 5 means this can't be 5, so this is 6, which makes that 5. Neither of these can be 5, so therefore this must be 5. Remaining digits here are 6 and 7, and they still could be both 6 or 7. But this can't be 6, therefore it must be 7, which makes that a 6, which makes that 7. That can't be 5 or 7, so this is 9, which makes that 7. And the remaining digits here are 4 and 1. And thanks for doing my first ever puzzle. Very cool. Congratulations. Uh, Only thing I would suggest is make sure you have the normal Sudoku rules apply. Yeah, and that's pretty much it. Because there could be potential confusion there if you don't have that rule set. You could just even just say, again, normal Sudoku rules apply, and just leave it at that. You don't have to explain that, because you have me to do that sort of thing. Anyways, congrats, Felix, on your first puzzle. It's a very cool one. The logic here was very sound. It was very nice going through it. And I hope you enjoyed this solve of this puzzle. And I'll see you next time on Frank Puzzles. Take care.